Oh, alright. We should be live. I'm going to do my usual sound check, which for some reason I still can't do in the browser. From this like stream manager view. I really need to work this out. Okay. Just need to hear myself say a few words. Beautiful. Beautiful. Okay, we're good. We're good. Oh, Boardplate followed me because I raided his stream. That was fun. That was fun. Okay. Just need to post a link to my Discord, then we'll go live with more PS2. Okay, I think we have everything in line. Let's do it. Let's go live. Let's talk about the PlayStation 2. Let's roll up our sleeves. It's going to be... Actually, let's not roll up our sleeves because it's really cold. It is going to be a gritty stream. It is going to be a serious stream. Okay, so... Hi, I'm Tom Marks and I talk about code. Welcome to another PlayStation 2 homebrew live stream. Today we're back doing stuff with the vector units. We are going to be trying to draw something to the screen. We failed to do that yesterday. Today's the day. I can feel it. I can really feel it. We're gonna draw stuff. We're gonna solve all of my problems and it's gonna be great. I'm gonna do another quick overview of what's actually going on here for anyone who's jumping in at this point, because I didn't actually draw on this diagram last time, but this is a really cool diagram. This is the PlayStation 2 CPU. Currently we do all of our work, all of our 3D, everything here, and that's really slow and bad. But when we want to draw something currently, my engine kicks stuff out to the graphic synthesizer via the GIF. When the graphic synthesizer is just the renderizer, the rasterizer for the PlayStation 2. I've been trying to rewrite my code because ultimately I want my 3D math to be done on this vector unit, which does 3D math very, very quickly relative to the PlayStation 2 CPU. And it can kind of do it asynchronously as well. It's just the right way to do 3D on the PlayStation 2. If you played a 3D PlayStation 2 game, you know, except for a very few launch titles, maybe, I think all of them. Let's just say every meaningful 3D game on the PlayStation 2 is going to do everything on the vector unit. All of the maths, pretty much. Maybe VU0 as well. But anyway, VU1's kind of the special one, because VU1 can then kick it straight off via the GIF to the graphic synthesizer. But we're not doing 3D on the vector unit yet. We are taking our time. We are taking it in chunks. Today we're just trying to interact with the vector interface, and we're going to use that to send data directly onto the graphic synthesizer. Okay, once we do this, the next step is to be able to do this and then also kick data straight through here, and then eventually we'll actually write programs that run on here too. But today, just this part is broken, right? Just the part where we talk to the VIF and use it to send data directly to the GIF and eventually the graphic synthesizer. So let me show you what happens when I run my code. Let me jump to the correct scene so I can show you what happens when I run my code. This is a PlayStation 2 emulator and we have a magnificent black screen, okay? So, and what actually happens, I've kind of got all this stuff being dumped out. It dumps the whole buffer for what it's trying to draw, and then it freezes. It hangs. There's no work being done. There's a little bit of work being done. The graphic synthesizer, if you can read the numbers in the top right of the screen, there is a little bit of work being done. The CPU is kind of busy looping, I think. What's interesting, because I had a little play with this from last night. Where are we? What did I change? I realized I'd misread a few things in the docs, so we'll talk about that in a sec. But one thing I did actually try was to just go back to sending data directly through the GIF. And that's what I'm running right now. Let's just do export platform equals PS2. That's what I'm doing right now. And so basically what was working before is now broken somehow because I added a bunch of code that does a bunch of different stuff. So that's fun. We've got a regression. And thankfully I know exactly where to look for the regression. The annoying thing about this regression is if I dump this out to some kind of log and then open up that log, I can look at this buffer. Actually, this is really ugly. Let's just look at it in less. I can see the exact data I'm trying to send to the GIF and it all looks correct. So I don't actually know what I've broken. So that's wonderful. That's really wonderful. So that's the first thing we need to fix today, right? That's the first thing we need to start digging into. CX Links, welcome. Thanks for stopping by. This is going to be a big stream. This is going to be a frustrating stream, but hopefully it's also going to be a productive stream. So we're just going to have a read of this buffer, okay? This is a DMA tag. This says that we're sending hex 29, which is 32 plus 9, which is 40, what is it? 32. It's 41. 41 things to the GIF, which is cool. GIF channel 1, I guess. Oh no, CNT, continuation. Sorry, we don't say that here. That's not part of the DMA tag. We then set a register in the GIF, register 47. We set to this value. I can't remember what 47 is, but that's okay. We set 2 registers, 1A and 1B. We set another 2 registers, which is the prim register and something else. This is like a floating point number. Maybe this is color. Anyway. Actually, yeah, it would be color, because I'm pretty sure I clear the screen to 2B, 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 because that's my favorite shade of gray. Then we draw a bunch of rectangles in packed mode, which is fine. This clears the screen. I need to re-implement this myself. This is still part of PS2 SDK. Now, after this, I jump into my code, where I set register 47 to something else. I can never remember what 47 is. I set the prim register. I draw 3 loops of 551. So 3, 1, 2. Oh no, sorry, I set 1 loop of 551. So I draw 1 triangle, 1, 2, or 1 rectangle, depending on what I've set the prim register to. I guess this is a rectangle, right? Because it's my rectangle example. And then I finish the draw, and I have a DMA tag that says this is the end of the DMA transfer. So this looks correct. All these numbers pan out. I can manually parse this and assert that this looks like a correct buffer. So something's gone wrong. Now, I'm gonna make my simulator. And this is just a Linux program that lets me run a simulation of what's going on. And something very strange has happened. CX Links, yeah, no, I mean, look, no one knows anything about PlayStation 2 development these days. It is a real, it's like a frontier. It's like I'm just rediscovering ancient knowledge, you know? So what's cool about this is, rather than having to boot up an emulator and stuff, I can just dump a bunch of garbage out to a log file, and I can see what's really going on every frame I draw. Now, for some reason, trace logging has turned off, but that's okay. Maybe I haven't built this correctly. Anyway, this is basically every frame, right? So from here to here is a frame, I think. Like, we start the frame by waiting, and then we end the frame by waiting, maybe. I don't think we double wait. Maybe we do. It looks like we're submitting data to both the GIF and VIF0. So somehow data appears to be going to this VIF. Currently, in the thing I'm trying to do right now, I just want to send data straight from the CPU to the GIF. So somehow I've messed up this code in a really, really serious way. And this is good. This is good. Now, what I found last time was the constants I was using for DMA channels were a little bit flaky. Okay, so let's do what I did last time. First off, let's think about where my DMA submissions happen. I think there might actually be one here, and there is. So I do a DMA send normal to channel 2. I appear to have already run into this, right? Because channel 2 is the GIF. I'm not even using their PS2 SDK constants. Maybe I've already hit this problem before. So that's good. That's one of my submits. But then the other one, like, where does this come from? Where is it? Kick VIF, kick GIF. Now, last time I replaced the PS2 SDK constant with this, which I think was correct. Now I'm going to replace my PS2 SDK constant with this, which is hopefully also correct. For some reason, every time, I didn't fix this off camera, I said I would. I have to recompile Lua every time I do this. Now I'm sending everything to GIF. So let's make clean all and see if we can get this to run. Again, recompiling Lua, which is always the slowest part of this. I need to finalize. I have a branch that decouples all of the Lua stuff. Like, it kind of makes it optional. Okay, well, this is good, right? This, at least we know it's going to the right channel now. But yeah, like this Lua stuff is a little bit slow. It would be nice to be able to build a really lean binary that relied on all this stuff as some kind of library, maybe like it distributed as a .a. I don't know. Like a dynamic linking bites me every time on the PS2. Oh, I could build my own linker. That would be fun. There is also ERL. There are things that exist. There are solutions to this problem. Okay, so we're kicking stuff to the GF and it's not working. And part of it, like this wait is fine. I think what actually is a struggle is the wait draw finish. And the wait draw finish, does that happen in main? Draw finish. Yeah, draw wait finish. So what if I just get rid of this, right? What if I just stop waiting for the draw to finish? Still hangs. Okay, let's undo that. Actually, no, that's okay. PCSX2 QT. We're gonna run. We're gonna run our binary, and we're gonna use a PS2 SDK flag called debugger, I think, which is gonna break on our entry point. This means we can come in and see where we're actually hanging this time, because this might be different to last time. Okay, so this is okay. We can probably run to maybe here. That's where we return. Maybe run to here. That's okay. So this function. So let's maybe break just before it. We'll reset the system. This is good. I'm glad I've learned how this debugger works a little better. Let's step into this function. Kick GIF. Okay, so it's in here. It's the DMA wait. It has to be the DMA wait, which I'm guessing is going to be maybe this one. Nope, that's okay. Last tag loop. It's not this, because then we have to submit. This is DMA end. Printf. That's maybe, yeah, print buffer. Okay. Send chain. This time we're freezing in send chain. So this is actually a different place we were freezing to yesterday, which is good and bad. So let's keep this breakpoint for now, I guess. Let's get rid of this one. Okay. Crap. I didn't mean to hit that. That's okay. Let's step into this. Not that. Step into this. Oh, hold on. No, it's not the function I thought I break pointed. This is where we're looping forever, I guess. Draw DMA wait fast. DMA wait fast. So for some reason, we're waiting for something that never finishes. And that's okay. That's okay. So it is actually here in draw kick GIF DMA wait fast. So we hang here forever. Now, what can make us hang forever? Okay, what things can trigger a hang forever in a DMA? Why might this never complete? And that's actually kind of tricky. So let's look at our log real quick. Okay, let's look at, oh, we don't have a buffer here. Okay, so let's make run and dump that out to a log again. And then let's look at this log. Let's look at this buffer. Okay, 29. So what did I say that was? 41? Is that right? 32 plus 9? That makes sense. So how many lines are there here? That's 41 lines exactly. So that sounds right. 41 quad words. One. So this DMA tag essentially looks perfectly correct. I don't know why it's blowing up. Here's another thing I can do. So let's go get status. Let's just stash these changes for now. Okay, let's grab the main branch. What if I make run this? What's in main right now? I can't remember. Cool. Okay, so this is good. So we have something here. I just want to make sure I have everything nice and closed because I'm changing branches. Main.lua. Let's change our script to the basic rectangle example. Beautiful. Okay, and we have this buffer. Okay, so this is good. This is what I want. We can look at what this buffer says, and it looks pretty much the same. Okay, we'll do a comparison. We'll do a side by side. Oops, that was the wrong paste. Now let me just quickly record a macro that will clean these up. How do I run a Vim macro on all lines? I can never remember. It's like the first Google thing, Vim run macro. So cool. That's not what I wanted. Okay, let's grab the other log. Because these should be the same. These should be 100% the same. Manually debugging the buffers. Let's make a file called tt2. That's also not the right clipboard. What is wrong with me? Wonderful. These look very similar. These look identical, right? These look identical. So what if I say, what am I, diff tt and tt2? They're the same. So that's good. That's really good to know. It just isn't very useful for me. Okay, what is happening? What else have I changed, right? What else has changed? What am I doing? What else is going on? So let's just poke around here for a second. I guess let's go get diff 3D. What's changed in the 3D branch? Okay, so, I added a weight. Huh. Or I removed a weight? So do I know, wait, did I stopped waiting before I called on frame. Could that be it? That's a difference. That's a difference. What else? What else is going on? What else is going on here? So red, okay. This is okay. These diffs are a bit weird. Maybe I should try the different diff mode. This seems fine. NCNT. DMA end. DMA tag. That all looks the same. We've kind of half done a job here. I see other problems. As I scroll through this, I see other problems. Okay, kick. DMA send chain. See, it's funny, right? Like this constant worked. Maybe there is something wrong with me. Maybe I'm the problem. Okay, let's... Oh. Let's go back to the 3D branch. Let's quit everything that we had open. Okay, so we're going to go into main.c. On frame. We're going to re-enable this wait. Okay, and we're going to make, and we're going to make run. And we are running the wrong, that's not what I wanted to do. Well, not the wrong example, just not the example I want to be running right now. See, now this never finishes. Like this is a bit weird, isn't it? Well, it looks like we freeze here. But why is that? What's different? What have I done so differently? What have I done so differently? It's a bit frustrating. It's a bit maddening. DMA wait fast. DMA wait fast. Like, why does this work in one place but not another? What is going on? What is going on? I'm just like pulling this up side by side on my other monitor so I can really have a look. And try and see what has changed. DMA wait fast. Like, this is literally the first frame, right? What have I done that broke this? Right? Or is it the second frame? Do I draw a frame? This is it. This is the start. Initializing at DMA stuff. Bind a buffer, make a buffer. Man, that's so weird. That's so weird. Surely I've done something else weird here, right? Like, there's something I'm missing. Has GS and init changed? You know? Like, it hasn't. It really hasn't. And we've got trace logging. So it literally does not reach, it literally does not draw a frame. It literally does not draw a frame. And we can fix this. We can fix this. We can fix this. This is fixable. I can do it. I know I can feel it. I can feel it. Okay. Sorry, I've just got to... it's hard for me to show this on stream, but I do just have to kind of look side by side because I don't really know what other inroads to make here. Frame start hasn't changed meaningfully. And I'm submitting the same buffer, so it has to be in how I actually submit it. So let's say draw kick. Okay, so we update the last tag loop. Yes, we end anything that we're in right now. We update the buffer size. We say DMA send. We print the buffer. But we never even get here. Why? Here's the other thing, right? The other thing that's changed. Okay, the other stupid thing that's changed is where do we initialize? Oh, where do we initialize? DMA.c. Oh, so it's in the Lua side. So let's go eg rect. And let's just stop initializing VIF1. And that gets further. Right? Am I crazy, or does that get further? So when I'm initializing VIF1, I die at begin frame. When I don't initialize VIF1, I don't know what the hell happened there. When I don't initialize VIF1, I actually try drawing a frame and then get stuck waiting for it to finish. Okay, so somehow initializing an extra DMA channel is broken. What does DMA.c do? How does this do it? Fast waits. Okay, now there is actually an example that Phobes sent me yesterday. Phobies sent Phobes. I think it's Phobes. I've been calling him Phobes. He's never called me out on it before. And he showed me this, right? So this is his example. Now DMA. Okay, so this doesn't have a... Oh, well, actually, hold on. This maybe isn't the entry point. Is it? No, it is the entry point. Oh, wow, he's got some stuff baked in here. So where does DMA channel init happen? Okay, this is where I have to now, like, dig into freaking PS2 SDK and work this out. initGS. This is his function. initGS. But this isn't a GS initialization. See, does he not initialize channels? Or is this a secret PS2 SDK thing? Okay, so what if I come into, let's get a new window up. So DMA channel init. View on main, samples. Oh, this does DMA channel initialize, samples. So it's either in samples or DMA.c. DMA channel initialized. The only things that call it. Oh no, hold on. So DMA source DMA.c 306. What function's this? DMA channel receive chain. Oh, it actually. Hold on. Send normal. Receive chain. Receive normal tries to initialize the channel first. I don't know. It seems like you should do this. But then why does it break? Like, what does initialize? Where is this? Channel initialize, sorry. TLIze. What does this do? Is it just unnecessary? Let's look at one of these examples that actually does initialize both. So EE draw samples vu1 main.c. Okay, and this channel GIF, channel VIF1. So this is exactly what I'm doing. It does fast waits. It builds packets. Word clock prim, send texture, clear screen, init drawing environment, init GS, draw cube, packet 2, yeah. So this does all the packet stuff. It'd be really interesting to dump the buffers out of this. DMA init. I could just add a little flush cache in here. I could just do that. That can't hurt, right? It can't hurt. And we die on begin frame. That's okay. That's okay. What if I initialize both? Okay, so it's not initializing both, it's just initializing VIF1 at all. Well, but I can't put a breakpoint somewhere here. This is what's hard. I can't put a breakpoint because it doesn't break here. It then breaks when we try and wait at the start of the frame. So do we just not DMA wait at the start of the frame? Maybe not. Maybe that is incorrect. But it works for GAF, right? Well, except when it doesn't. So except when it doesn't, because waiting for the draw to finish, it just never completes. But why? Because we're sending the right stuff. We're kicking it to the GIF. Whoa. Okay, that works now. So when I actually kicked it to the to the correct channel, it worked. Thank you, git state. But once I add this initialize, it stops working, which is a bit odd. Why would that stop working? Why would that stop working? This is a good question. This is a question I don't have an answer to. Okay? Why would it stop working? What is going wrong? What has happened? Oops. What if I don't do fast waits? That. We're just gonna carve away at this until it works, right? So is that... Huh. Maybe you can't do initialize, fast wait. Because if you look at what the PS2 SDK example does... Oh, that was actually the right thing. Hold on. It does initialize, fast waits, whereas I'm doing initialize, fast waits. Maybe... Can I do like... I can do like varargs, right? Lua get top. So let's go even Okay, let's try this. So let's go for 0 I less than arg c I plus plus. 1 plus I. And then we're gonna loop over this twice, because this is something you call once at the start of your program. Let's try this. Let's try this. Let's try making it a varargs function. So instead of this, we'll do dma.vif1, right? You give it a list of channels. We probably need to check the logs here. This is a good idea, though. I think this is a solid idea. I think this has potential. I think this has a lot of potential. Where are we? VRAM alloc. Init channel 2, init channel 1. Set fast wait, set fast wait. So that still doesn't work. That's okay. If that's kind of funny. If we just stop doing fast waits. Hold on, whoa, I didn't compile any of those changes. Yeah, okay. So we can't set fast waits for VIF1 for some reason, even though this code literally does it. Oh, we can, we just can't wait before. Maybe we shouldn't be waiting there anyway. I don't know if this wait adds anything of value. Okay, so maybe that's it. Maybe that's what we want. Maybe that's what we want. Maybe that is what we want. So let's see if we can send to the VIF now, right? What if we go back to common and kick VIF? And then we have to add this back. Oh no, we're starting a VIF code. That's interesting. I don't think the VIF code was there. Yeah, okay. That makes sense. I mean, we've got a VIF code. We've got one. It's correct. It's VIFcode direct. Send to VIF. Interesting. Interesting. Okay, we're getting here. We're making progress. We are making progress. First things first, I'm gonna stop setting fast waits, because this scares me. Except I need to make... That's a bit of a foot gun, not rebuilding when I make. Okay, so the wait draw never comes off. So this probably just means I'm not sending this buffer properly, but it all looks good. It all looks good. 2829. Oh, there was actually another thing I wanted to try, right? Which... Oh, so hold on. This is wrong. This is wrong. I thought I fixed this. This is wrong. The VIF code doesn't go here. Okay? I read this. I read this and I misunderstood it because I saw this DMA packet example when DMA tag is transferred, and I'm like, oh, the DMA tag and the VIF code get packed together into this 128-bit thing. This isn't the case because I'm not transferring the DMA tag. I am not transferring the DMA tag, so it should look like this, okay? And I think what I actually want here is the DMA tag, then nothing. Then I want 3 VIF code NOPs, then my VIF code for direct transfer to GIF. So this is good. This is good. This puts us back in a place where, let's re-enable this for now. This puts us back in a place where we know what we're doing, where we have direction. It's taken us half an hour to get here, but we finally have direction again. Okay, so what this means is when we start a VIF code, the first thing we're going to do, we're going to do command buffer align head. We're going to align to this quad word. Maybe. Or maybe not. Because see, this actually isn't correct. So probably what we should do instead, okay, maybe when we say, so when we say frame start, maybe not in frame start. Maybe we need like some, yeah, okay, no, we're gonna do this. We're gonna align to the head, and then we're gonna say VIF code we're gonna put some NOPs. We're gonna do some NOPs. We're gonna do 3 NOPs. We're gonna do this here. We're gonna do this. Zero, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. Let's try this. If I make this has a problem because where's the error? Hold on, error. VIPcode not undeclared. That's okay. Where do I get that from? Oops. I'm pretty sure NOP is just zeros. So really, this is a little bit more involved than it needs to be, but that's okay. What if I make run now? This feels better. This feels better. This looks right because 1, 2. So the VIF code goes kind of at the end. 1, 2, 3, 4, 5, 6, 7, 8. It's the last. God, these are a nightmare to read. It's the last. What am I saying? It's the last uint 32 in this thing. And then you have 2 8 quad words afterwards, which is correct. Now, I'm going to go back in here when we VIFcode end, and I'm going to say -2 just to try it. And I'm going to say just without -2 just to try it, except I need to make run. And that's it. We're sending via VIF. We're sending via VIF. We're doing it. It's happening. Okay, there we go. We're drawing to the screen VIF. That was an absolute nightmare, but it is working. Cool. Let's see if we can draw something more involved. Main main.lure. Let's try and do a cube example, which may not actually be a cube at the moment. We'll see. Yeah, perfect. Okay, let me get a controller plugged in so I can move this bad boy around. I I've got my desk is ridiculous right now. My desk is ridiculous. It is in such a state. Okay, we can do it. We've got a cube. This is going via the VIF. It's not doing anything on the vector unit, but it is going via the interface that will eventually allow us to control the vector unit. Now, if I wanted to be really thorough, I would hardware test this right now. Right now. I would not delay, but unfortunately, I don't have a very good capture setup for hardware. So, it's time for my little donation break. You know, I don't love asking for money, but I'm hoping to get a little bit of money thrown towards the stream that I'm going to put back into leveling up the stream. I want to get an HDMI capture device, a better one than I have, because the one I have right now looks pretty garbage. And I want to have a better setup for plugging stuff into my computer, having a PlayStation 2 running, you know, you'll be able to see what's going on. That's my goal. That's my goal. 150 Australian dollars. I think that comes up to about 100 freedom dollars. And of course, there's no obligation, but it would be lovely to have this stream essentially support itself, because money right now, you know, I can't really prioritize a nicer HDMI capture card. But that is my quick little donation break. Also, if you donate, you will go on this wonderful page and you'll get a nice place of honor on my website. Back to code. Back to code. That's really exciting. Okay. Thanks CX Links for hanging around, by the way. It's cool. It's cool. It's been good to have someone on this journey. It's been a long time, but it's good to have someone on this journey. Okay. Gosh, there's a lot of stuff here. A lot of stuff to clean up. So I don't actually need this change, right? Source draw. This is a bad commit message, but we'll roll with it. Actually, I probably want to... do I want to commit that? Yeah, screw it. Like, I think this is okay. Actually, I don't know if I do. I've got to think about it, right? Because it's hard. I don't... the thing that I changed, right, was this variadic DMA initialization, but I don't know if I really want that. Right, these two changes go together, and it's kind of cool because it doesn't actually break anything, but I don't know if I need it. So let's try git stashing this, and then running it, and hopefully it'll still work. Yeah, it does. So actually, let's not dive into that change right now. Yeah, let's git stash. How do you set a message for git stash? Git stash stage dash, it is just dash m, so that's good. Dash m DMA init varugs. Nice. Okay, so that's so exciting. So let's just review what's going on. Let's also update my goals, right? Holy crap, we can check something off. So this is what's happening, right? Data is coming from the CPU. It's going via the DMA controller along the bus. It's getting sent to the vector unit interface, the vector unit 1 interface, and then it's getting kicked out to the graphics interface where it then gets rasterized in the graphics synthesizer. That's really exciting. That's really cool. It's taken me way too long to get this to work, but now it works. We can do other cool things because the VAF can be programmed essentially, right? It understands this certain format. If I scroll in the right direction, we're not going to think about unpack right now because that's going to be hard. And we can do all these cool things like set, write, recycle. I don't know what that means, but we can, oh, hold on, you can't see my screen. We can set all these cool things. Set the double buffer offset. What does that mean? I don't know. But we can explore these things, and we can start to upload data into the vector unit memory and then run a vector unit program. So the next step is use one of these wonderful things. No, hold on, that's the wrong way. Mark flush E, flush. There are all these subtle differences. Right, we can call a micro program in memory. Filling data. Stores the following for words. Yeah, cool. So that's part of MPG. So we can transfer a micro program, inline, which is cool. Transfer data to the GAF. That's what we're doing right now. Transfers data to VU memory. Okay, so we can dump our current what we're currently sending to the GAF. We can just dump that into VU memory and then run a program that just kicks it on. That's the next step. And then once we do that, we start writing code to do actual 3D on the vector unit. I'm so excited. I think I'm going to have to go and have a short toilet break. So I will be back in a sec. Oh, all right. Zymus, hello. Tiny Devil Games, welcome. Brings back memories. That's awesome. Um, have you done any PlayStation 2 dev, or are you just reminiscing about good times, cracking goals and making things work? It's also kind of funny that I had to take a little break as soon as people start trickling in, but this is life. We are gonna do more. We're gonna start pushing on. We're gonna do cool stuff. Tiny Devil Games, thank you very much for following. That's really awesome. I love to see it. Okay, so this branch is getting really out of control. This is a really, really silly branch. It's so long-lived. I just can't. But we're gonna keep pushing through. It goes back to October last year. I don't know. Maybe I should just merge this now because it does 3D and it does VAF. I really want to have better branch hygiene. It's very hard for me. It's very hard for me. I'm just going to keep pushing on for now. I can always fix things up later. Okay, so. Actually, no, I'm going to branch for this. I'm going to branch. We're going to make a branch called VU1, which is exciting. We need to do a bit of plumbing for this. So we're going to make a new folder in source called VU1 prog. This is going to contain our vector unit assembly. Let's see if we can assemble a simple vector unit program. VU1 prog. We're going to call this identity.vu1asm or VUASM. Maybe just ASM. Because it's in a VU1 prog path. Yeah, cool. Okay, so identity.asm. All this is going to do. Well, first off, I mean, like, let's see if we can find a vector unit program that we can use, because like, where does this come from, right? Like, what's going on here? What's going on here? What program? This uses VU1, right? This sends stuff to the VIF. So what program does it use? Tag, GIF tags. Where's the VU1 tag? What's going on? What's going on? GS VAF flame. Let's see. NC handler. Upload texture. Draw packet. GIF. XYZ. Send it to the GIF. But then this, what does it send to upload texture? See, it sends. It just uses VAF. Direct, 2 quad words, text. Okay, maybe it doesn't actually use the vector unit. Where was my wonderful PS2 SDK example? I suspect this is just gonna, it uses VCL, that's annoying. V1 microprogram. This is what I want. Okay, so this is generated, I believe, by a tool called VCL. Yeah. And this tool basically, XTC might be useful to look at. Thank you. Oh, nice. You did PS2 dev with PS2 Linux. So like back in the day, because PS2 Linux is amazing. If you haven't heard, the PS2 like has a Linux distribution, and lots of people made a lot of really cool stuff with it. It was a cool way to play around with the hardware. XTC. Okay. I mean, look, I think this is enough, right? Because I'm not actually trying to write lots of VU code right now. All I want is the xgkick instruction. And xgkick, if I go to the VU users manual, is this the one? Does this have the xgkick? This explains the whole pipeline, which I don't really care about right now. GIF control. This is the thing that transfers data to the GIF. Everything's hard-coded. Provides IS. I think IS reg. Or no, there is a register. Stores until it ends. Right, okay, VIO. So we have to give it an integer register. Can be used in VU1, cannot be placed in the E-bit delay slot. That's okay. VIFCode flush. May not wait for the end properly. This is a really great comment. It may not wait for the end properly. What does that mean? What do we do instead? It does kick you somewhere else in the manual to read, but that's scary. GIF considers the provided value as a GS packet address. Transfers the data as a GS packet. Leading GIF tag address. So the first GIF tag address. Also, I don't know how we end necessarily. Where do we, how do we, is this, okay, this is something I don't understand. What does code end mean? Well, maybe it's kind of in here. So we have to pick a register that's going to have the address. So the program will look like this. Not xgkick vi, maybe it has to be like a tab, vioo. No, hold on, vioo1. We don't want to use vioo because that is just like empty. So let's see if we can, what is it? MIP64 after dv PS2 elf. That's not it, sorry, it's dvp. Alright, so this is a bad instruction. Why is this a bad instruction? I don't know. What is missing to make this valid? So let's just show white space really quickly. Let's just copy and paste a thing in here. Oops. Without this first comma. Maybe? No? Is this all padded out with... There we go. So this is a space. That's the end of the line. I don't understand what format it actually wants these in. Let's try just like tabbing more, I guess. I don't know. Also, this is kind of weird. IBNE. Oh, right, yeah, branches and then it finishes. Okay, so let's put a tab here, like, well, except these aren't real tabs, are they? Let's just try spacing it out more. How do I change this? I need to think about my Vim config. Hold on. Which I don't do very often. I don't do this often enough. Config. It's in my init.vim tab. Soft tab stop. Is that it? Shit. I can never remember how this setup works. Okay, I think that's what I want. Nope. And that is a tab. Well, here's another thought, right? Can I actually assemble this code? dvp as. Yes, I can. Okay, so is there something else that I don't have that this has before the code? Does it need something? Does it need a label? Maybe? These are just spaces. They're just a lot of spaces. Oh, it's because it's capital. Hold on. That's really silly. Oh no, hold on. What am I doing? What am I doing? No, no, still not that. Nope. Cool. It's always the silly little things you don't expect, right? So what if I just like straight out copy and paste this line? Oops. Can I do that? No, I can't. What am I doing? Why? It's not that, is it? God, you know, sometimes your Vim skills. No, that's also not it. I can do this. I can do this. It's not that. There we go. That should be right. Yeah. Okay. So, can I assemble this? No. So maybe I do need a label before it. So literally copy and pasting from this program that works, it still doesn't assemble it. So that's a problem, right? That's a weird problem. What if I do something else? I mean, first off, what if I continue to copy from this? Right, what if I continue to copy? Bad instructions. They're all bad instructions. But it's the same binary. Oh, hold on. That actually, I missed the directives that were here. So I need a .vu directive and I need a .align for directive. And now it's gonna work. There we go. Weird that we can't obj dump it with the like corresponding tool that compiled it, but okay, we can compile VU1 code. That's good. That's very good. And let's see if we can upload it, I guess, right? Oh, it's all going to go in the same buffer, so that's kind of cool. So let's find this. Transfers the microprogram. Waits to the end and transfer the following num pieces. Okay, so we can put a microprogram directly in draw packets. I don't know if this is the best way to do it, but we can definitely do it. We could also upload it not this way, but let's keep using the path that we've established works. Let's keep using the established path, the road well trodden. Let's see. So MPG. We can open files, that's okay. Oh, we should actually also modify the make file. That's another thing that we should do. So let's, if we're compiling for the PlayStation 2, then we want to rule, actually no, if we're compiling for the PlayStation 2, then we want a rule that says if we're in VU1 prog I guess we kind of want to do this, right? Something like this. Because a lot of people embed these directly in their binary, but I think why not load them using the IO functions I already have? Like, just why not? It just makes sense. I think it's a bit simpler in some ways than relying on, these symbols, being like reading these symbols out of the binary, these kind of magic constants. Oh, that's also not what I want, is it? This is actually gonna be a bit more complicated than I thought because, well, first off, I need to read what I'm doing. This is the kind of fallback. If we're not compiling for the PlayStation 2, we probably want this to just generate like a dummy file, and actually we probably should do that. Maybe. Let's not do it right now. Okay, so we have vector unit. Yes, good. No such file. Oh, well that makes sense because we don't have a dvpas. Cool, we've got a compiled file. readelf v1 prog identity.vobj, and let's just read everything. Sweet. Now this isn't a raw, this is a proper elf. This isn't just a raw binary. Because we just dump the actual, we don't really just dump the actual program like text, right? So I guess maybe we need to, do I have to read an elf? Maybe this is more than I can bite off right now, actually. I might call it there. We got stuff onto the screen. We compiled some VU1 code. And we're using the VIF. It's good. Life is good. We're making good progress. I'm going to go hardware verify what I've already done. And I'm going to call it there. I'll do a little bit of work off camera. I know I always say that. But for now, this is probably, I'm not going to start this new huge thing right now. It's a little bit too much. But thank you. Oh, Tiny Devil Games says, looking at this is like being a family reunion, bumping into a second cousin you haven't seen for 15 years. I love it. That is such a good comment. That's one of the best chat messages I've ever received, I think. That's really wonderful. Let's find someone cool to raid, though. If anyone has suggestions, I'm always happy to take them. Otherwise, I'm just going to peruse software and game development for a cool-looking streamer to throw some love at. Software and game development. C3D game engine, that sounds kind of fun. That sounds very fun. Alright, who's live right now? Any tips for a good raid? Jellycar community showcase fixes, that's kind of fun. I think C3D game engine has a lot of potential. Let's throw tech 256 a raid, share the love. I will try and do some longer streams though. I think that would be really good fun. I think that'd be really good fun. Tech what's his name? Tech 256, of course. That's an easy number to remember. Have I done any PS2 decomp? I have actually recently made a randomizer for Kingdom Hearts Final Mix on the PlayStation 2. So not really a decomp, but I did have to dig through. Like I got it open in Ghidra and used the PS2 debugger, and I found a place where I could hook to run my own code. So I've done a little bit of poking around. I don't think it would be very good for a stream, but well, I did stream a little bit of it actually, but yeah, it's just a bit of a nightmare. But anyway, we're going to throw some love over to this guy. He is apparently, or they're apparently working on a 3D game engine in C, which sounds really cool. Let's go have a look at what Tech 256 is doing. Thank you so much for tuning in, and I'll catch you next time.